Today let us look at the one working of a vernier calipers. So we all know a vernier calipers consists of two scales. One is the main scale. Here you can see the main scale, and the other is a vernier scale. The vernier scale is a mobile scale. It can slide over the main scale. When you have an instrument, when you have an object to measure, you we attach it between the two jaws. These are called the jaws. And when we keep an object between the jaws, the reading can be noted here with a slide mechanism, right? So we all know the mechanism is that whichever division that is just after the main scale is called as the main scale division (MSD), and the division that coincides with the main scale on the vernier scale is called the vernier scale reading (VSR). Right. So the total length of the object is given by the main scale reading MSR plus VSR into least count. Now let us understand this why it is so. So the first thing, let us look at the least count. Why is the least count point? Uh, Suppose if this is a main scale which is having a each main scale division is 1 mm, let's say. So this is 1 centimeter 0 to 1, so that you have 10 divisions here. Each division is therefore 1 mm, and 9 such main scale divisions matches with the 10 vernier scale divisions. If you see 9 MSD equal to 10 VSD, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th division here matches with the 9th division, right? This is the 9th division of the main scale which matches with the vernier scale. Now we can understand each vernier scale division is therefore 9 by 10th of the main scale division, correct? So let's keep that in mind for us. Let's consider this as the object here that you can see. So this object here, this is the object that we are going to measure. Now this in comparison is very small, right? But let us see how we can measure this. So let's say I insert the object between the two jaws, and as you see, the first vernier scale division has matched the main scale division, right? So if you note previously, the red dotted line here indicates which division is matching. The red dotted line indicates here that the 0 division matches with the 0 of the main scale, right? So this is the perfect 0 position of the vernier calipers where the 0 matches with the 0. Now this is without any 0 error, right? So as soon as you insert this object in between the two jaws, this is slightly, this moves to the right slightly, so it slides on the main scale, and now the first division has matched, right? So this is the least measurement that we can get with the vernier calipers. We know what is the length of the object as per the formula. As per the formula, the length of the object is given by MSR plus VSR into LC, which means in this case the MSR equals to 0. So 0 plus VSR, the 1 year scale reading here is 1 into LC, which is nothing but LC, right? So that means the length of the object equals to the least count of the instrument. So whatever is the length of this object, that is what is the least count. When the first, right, in a situation, in the present situation, the length of the object becomes the least count of the instrument. Now, how can we get the length of the object? See, this particular length is fixed, right? So this is 1 mm, which is fixed, and we know that uh, each 1 year scale division is 9 by 10 of the main scale division, right? So this is 9 by 10 mm, isn't it? That's also known to us. Now that means basically this 0, previously the 0 was coinciding with this 0, but now it has moved to the right. If you look at it in a close up, you'll find that the 0 has moved little bit, right? So we know that already this is 1 mm. What about this? This is 9 by 10 mm. So how much is it moved? If you if you want to find the length of the object, which is this much, that is equal to the movement of the vernier calipers. Vernier scale has moved by this much, right? Which can be indicated by this length, right? So I can get this length by knowing what is the main scale division which the vernier calipers is matching, subtract it from the 0. So you can know that this is 1 mm minus the 9 by 10 mm. How much is 1 mm minus 9 by 10 mm? It's going to be equal to 1 by 10 mm, right? So that's where I can say the measurement of the length of this object equals to zero point 0.1 mm, or the so we have now established the least count of the instrument, which is going to be zero point 0.1 mm. The fifth division here is going to match with the main scale reading. It is going to match with the main scale. So now I want to find the length of this. Obviously, the length of this instrument equals to the length of this, which is nothing but the length of this minus the length of this, right? So here I can know that the length of this is, it's the fifth main scale. It's a 5 MSD, right? So it's going to be 5 MSD because 1, 2, 3, 4, 5, 5 main scale divisions, and the length of this is 5 VSD, 1, 2, 3, 4, 5, right? So the length of this is 5 VSD. So therefore the length of the object is going to be 5 MSD minus 5 VSD. So it's nothing but the the reading which the vernier calipers has matched the main scale, that is called the vernier scale reading, 5 times MSD minus VSD, right? So this value MSD minus VSD is also called as the least count, as we have just before noted, right? This is 1 MSD and this is 1 VSD, right? And the value MSD minus VSD is called as the least count, right? So thus after I know the least count, anytime a vernier scale reading matches a main scale, I can know the vernier, I can know the vernier reading equal to the vernier scale reading times the least count. In this case, you can see the zero of the vernier exactly coincides with the uh, 4 fourth division on the main scale. So we can know therefore that the length of this object is supposed to be equal to just the same value as this MSD, because the vernier scale reading is 0 in this case, right? So the length of this object is therefore going to be 4 mm. Now let's say the objects the let's say the object's length is little more, so that the first reading of the vernier calipers matches the main scale. So in this case the vernier scale reading is 1. So previously it was 0, but now it is 1. In this case I can know that because the length of the object is this much more than the main than the 4 mm, right? So the length of how much more is it from the 4 mm. How do I measure it? I measure it just like the previous case. If you look at it, the main scale reading MSR becomes 4, but the vernier scale reading becomes 1, right? So this length, this additional length, I can get it by just doing the same thing once again, which is 1 MSD here minus 1 VSD. So it's not the even though the main scale reading is not 0, but still the vernier scale reading just becomes the length contributed by the vernier calipers becomes the same thing, which is equals to MSD minus VSD. Therefore I'll know that this length, which is the additional length apart from in addition to the zero point 0.4 mm, is given by 4 plus, which is the MSR, 4 mm plus MSD minus VSD, which is going to be um, LC again, right? So in general, if it's any other vernier scale reading, I can tell the length of the object equals to MSR plus VSR into LC. Now let us try to understand the zero error. In case of the zero error, where even when there is no object that is measured, we have the zero of the vernier calipers which doesn't coincide with the zero. Now this can happen in two ways. First case is like this, where the zero of the vernier calipers is past the zero of the main scale. So this is called as a positive zero error. Why it's called positive? The simple reason is you can see that the length of the object, even when there is no object at all, is pointing to a positive value of 0.04 mm, because the fourth division of the vernier calipers matches the fourth division here. I mean, therefore it's evident that the vernier scale reading is 4. So 4 into LC is the length of the object. So even though there is no object here, we are getting an additional length of 4 times LC. Therefore it's called as a positive zero error. Note that zero error is to be subtracted from the reading always, right? So whenever you have a zero error, the length of the object is given as the length of the reading minus the zero error. How do I get the length of the reading? Which is MSR plus VSR into LC. So in this case, the zero error is taken as 0.04. So how do I get the zero error in this case? If it's a positive zero error, the zero error equals to the vernier scale reading that matches the main scale times LC. That becomes your zero error, and that has to be subtracted from the length of the reading we obtain. Now let's say, because if there is no zero error, let's say the zero error is absent. So the zero of the main scale and zero of the vernier scale exactly coincide. So when there is no object that is present, the zeros are in alignment. Unlike the previous case where you see that even when there is no object, the zeros are not in alignment. This particular length is an additional measurement which you are going to receive for every object that you take. This is analogous to the zero error on a weighing machine. Let's say a weighing machine has by default 100 grams set on it. Even when we add any amount of weight, the 100 grams gets added to the measurement that we take, which has to be subtracted. So this is identical to that. This 0.04, which is the zero error, is in addition that is present for every object that we take the measurement in. Hence, this zero error has to be subtracted. Now let's say with this zero error instrument, we take an object and we take its measurement, and we see that the fifth division here coincides with the one year division. The fifth division on the vernier calipers coincides with the main scale. This means that the vernier scale reading here equals to 5, right? So the length of the object is therefore equals to the main scale reading, which is 0.4, which is the main scale reading is always that main scale uh, division which is just preceding the zero of the vernier calipers. In this case, it's zero point 0.4. So the length of the object is going to be 0.4, which is MSR plus VSR. VSR is the 5 times the least count. Least count of this instrument we have already established is 0.1 mm. So if you have to write it in centimeters, it becomes 0.4 mm plus 5 into 0.01 centimeter. So it becomes point. Now this is the length of the reading that you got from this particular apparatus. But we already know this instrument has got a zero error of 0.04. That has to be subtracted minus 0.04. So therefore the total length becomes 0.45 minus 0.04, which is 0.41 centimeter. If the same has to be done in mm, it is 4.1 mm. We can see the case of a negative zero error. In the case of negative zero error, the length of the object that we get, the reading that we take, is going to be shorter than the actual length of the object, because uh, it takes a minimum amount of length to come to the zero, to show it as zero. Right now it's like a negative measurement. So how much negative is it? The sixth division here is seen to be coinciding the main scale. Without the zero error case, we know that the 10th division of the vernier calipers coincides with the main scale. So we want to find how much is this motion in this direction, right? How much is this motion? So we have to count it from here. So it has the sixth division now coincides with the main scale, which this particular additional length. How much is this length? So we know this is 1 2 3 4 4 MSD, and we know this 1 2 3 4 4 VSD. So we can know that the additional length here, which the vernier calipers has moved beyond the zero, is given as the 4 MSD minus 4 VSD. So which is going to be 4 into LC. So this can be seen that this 4 here is a value which is complementary to the 10. So the value in actuality which coincides with the main scale is 6, but the error associated with this instrument is not 6, is not 0.06, but instead it is 10 minus 6, because we are counting from the other side. Therefore 10 minus 6 into LC becomes our error associated with this, and because it's towards the left, it's called as the negative zero error. So this becomes minus 0.04 centimeter. So this zero error also has to be subtracted. But as you notice, because it's negative, therefore the total length of the object becomes greater than the reading. As here, you can see the zero error in this case is a negative zero error. Therefore, when the main scale reading is 0.3, And when the vernier division that matches here is 7, the length of the object is taken as MSR, 0.3 plus VSR, which is 7 into LC, right? 0.3 plus 7 into 0.01 minus, this becomes the length of the object. This has to be subtracted with the zero error, which is minus 0.04. So the total length of the object therefore becomes 0.41 centimeter.